to the IT Fundamentals Training Series. My name is Mark Haupt, and I'm here to share with you today a little bit about processor sockets and memory slots. So here we go with sockets and slots. All right, let's take a look at the difference between sockets and slots. First of all, your processors are going to use sockets, and your memory is going to use slots. And in this session, I want to share with you actual pictures that I put together on a PowerPoint that we can go over. So we're gonna switch. If you're on audio only, I would encourage you to go back and look at this later on and actually watch the video so that you can see what we're about to hear to talk about. But I'll do my best to present these in an audio format as well. All right, so let's get started with our PowerPoint. And let's take a look at, first of all, we're going to look at processor slots. First of all, let's understand that there's a couple of different, actually three different types of processor slots that are out there. There's what's called the PGA, or the pin grid array. There's the LGA, which is the land grid array. And then there's the ball grid array, or the BGA type of socket that's out there. Now, the BGAs are very uncommon and very difficult to deal with. They require you actually to learn how to solder and potentially ruin your motherboard if you aren't very precise and very good at doing it. So the book and the training series is going to pretty much stay away from the BGA functions, and you don't need to know anything more than what I've already told you about for the test, knowing that it exists and that it's a difficult form, and you're probably not going to see very much of it. But what you are going to see is the PGA and the LGA. Again, the pin grid array, PGA, or the land grid array. Now on the screen, I have for you what would be a pin grid array, and you could see that socket there. The two types, not only the socket that the CPU goes into, but also one of the CPU chips upside down. And really, this is the difference between the LGA and the PGA function. On a PGA, you're going to have pins that are sticking up or sticking out of the CPU socket, whereas on the LGA, the pins are on the socket itself, and they don't stick up and are not as prominent as on the PGA. So on your PGA, let's focus on that for a moment. You can see on your screen right now that on the left-hand side, there is a white socket, much like a wall socket, in the sense that what will happen, you plug in your light switch, or you plug in a fan or something like that into the wall. You have three prongs that go into a designed section or designed pieces within the wall socket for your electricity. And what you're looking at here on the screen is, on the left is that socket that you insert the chip into, and on the right is a chip, which is the green part, and that's actually the chip board, with the chips on the inside, the centerpiece of that, and the sockets or the pins for the sockets are sticking up there, and they're usually made of copper in order to properly conduct electricity. All right, so on this image here, I've also identified that you really can't put these in the wrong way unless you're forcing it, because as you can see, if you look very closely, that the socket is a square, but in the top left-hand corner, that square has a slightly different set of sockets or holes in it that are more at an angle instead of squaring off. And if you follow the red line across to the CPU chip itself, the example there, you can see how those are lined up on the chip. So you literally would put the chip down inside of those. Now, on the left-hand side of the screen here, you'll see the socket, and on the left-hand side of the socket, you'll see what looks like a lever or lever arm. Before you try to put your CPU into this socket, and before you try to put those pins into the socket, you need to open that lever in order to open the gates, if you will, that are underneath that socket to allow you to submit the CPU chip into the socket. So open that lever, drop your socket in gently and literally align it, and then just let it go with your hand right above the socket so it slides in there. And then you put the lever or lever back down to lock it in place. And at that point, your CPU is in place for a PGA. Your LGA is very similar. There's going to be a lever or a series of levers that you have to open up, probably a cage, if you will, that will be on top of where the LGA chip card goes for the CPU. You'll lay it in there. Usually the LGAs will have arrows printed on the circuit board itself and also printed on the socket or the motherboard. So you align the arrows, you lay that in there, and then you take your levers and you place them back down in the locked position, and that will give you the chip secured in there. So LGAs, PGAs, and chips. So on the second page that we're looking at here is an example of the LGA format. And you can see on the right hand side how although there's a similar scenario where there's a green circuit board and the chips for the CPU are in the center, the sockets, or I'm sorry, the pins are replaced with more of a flat surface to our contact points. And then on the left hand side, you can see the socket that it goes into, and you can see that the raised pins, if you will, although much smaller than the PGA version, are available there for receipt. Now on this particular chip, you can notice that there's little half circle indentations on the right hand side of that chip, and if you look closely at the socket, you will see the corresponding indentations. So again, you cannot, unless you're forcing it and doing wrong, you cannot put this chip onto the socket incorrectly. And again, once you lay the socket in there, make sure that you lock it in place to ensure that it works. Now, I'm going to let you look at this YouTube link here, where it says I added a video here from an external source called LGA versus PGA, where they go into this video and they talk about not only what I just talked about in more depth, but also demonstrate how it's done, and also then move forward into talking about the differences of the manufacturers, the chips, and the performance that you get out of that. So I would recommend that you take that link and you go to that YouTube site and take a look at it there. Now, there's another component that's very important for your chips. It doesn't matter whether it's a PGA or LGA, and that's a heat sink. So all CPUs generate an enormous amount of heat, to the point that if there is not some sort of way to remove the heat from the CPUs, you could possibly melt or burn your motherboard and eventually your CPU as well. So what you do is you place what's called a heat sink on top of the chip. Now, what I have in this image here is a heat sink plus a fan. And what the fan would do is it would extract the heat, pushing it out into the case. There's another fan inside of the case that would then extract the heat from the case out into the open air. Now, the concept of a heat sink is this. If you think that heat will always rise and it will go towards the coolest point. So heat will, kind of like a magnet, if you will, it will rise and it will go to the coolest point. So what they've done is they've taken these metal heat sinks so that the heat is just distributed evenly across the base, and then they've created these metal posts or veins, if you will, that go up. And what happens is the air will flow through those veins. It will remove the heat from the higher portions of those, because as the air moves from the fan across there, it will extract the heat, and then as it extracts the heat, those higher in the posts will be cooler, and therefore the heat will continue to rise, and magnetically, if you will, not true magnetic, but just the idea of moving upwards in that heat sink. And so it's a constant flow, like a river. It's a constant flow of the heat coming off of the CPU, moving upwards on the heat sink, the fan pulling that off and ejecting that, if you will, or exhausting that out of the system. Now, the next thing I want to take a look at today are memory slots, okay? And much like the CPU scenario, memory slots are on the motherboard. much like the CPU socket, they are embedded into the motherboard. And we talked about bus yesterday, so that there's a bus or a communication path that goes from the CPU to the memory slots. Now, keep in mind from one of our first episodes that the purpose of memory in the form of RAM is that these are what we call volatile memory, which means that it is going when the power ceases to go to that slot. And so when we turn the computer off, the memory will be lost. Now, if you have non-volatile memory, you're talking like an SSD, a solid state drive, or a hard drive or something like that, the memory is retained. So there's different kinds of memory chips. What we're specifically talking about here is the volatile memory, or RAM, random access memory. All right. So in this picture, and what's typical on a motherboard is that the RAM slots are sitting very close to the CPU, because if your physical distance between the CPU and the RAM slots has a short distance bus ride, if you will, there's a short distance of bus between those two, that is going to speed up the process and therefore speed up what you see on your monitor and how fast your computer's operating. So this particular computer, and most computers that are desktop types, will have the capability of having 4 memory slots. Now, most of your laptops are either 1 or 2. Now, the type of memory that we're looking at here is called a DIMM, which is a dual line, or I'm sorry, dual inline memory module. It's a DIMM, so DIMM. And for laptops, that would be a small outline DIMM. So it'd be a much smaller chip. It would look slightly different, but the concept is the same. And then you're looking at putting as much memory as you can inside of these slots. Now, if you'll look very closely there, each one of them is a slender rectangle type of function. In each side, they have a tab on each side. So in order to put a new DIMM inside of one of these memory slots, you would press down gently on either side of the slot you're wanting to put your memory into, and you would then put your memory slided into those slots. Now, in what appears to be the very center of these slots, you will see a little line inside of that slot. It's actually slightly off center, and if you had a memory chip or a piece of DIMM in your hand, you would see that it's slightly off center. Again, this is designed only for one purpose, and that's why you cannot put it in backwards. You cannot put it in wrong unless you are forcing it. So the way that you would put this in is you would slide your first of all, align your memory with the slot there, and then make sure that line that's in the middle is lined up with your memory chip or the memory card. And then you would just, on either edge of your memory, you would just gently press down, and you're going to have to give a little bit of force, but enough that you'll hear it click in place usually, or feel it click in place. Now, the other thing with these slots is you'll notice that there's 2 different colors. There's a yellow and an orange. And that is because typically in a desktop computer, you're going to need to operate in pairs. So if you want to have 32 gigs of memory, you're going to have two 16 gig modules. One will go in each of those pairs. It doesn't matter whether it goes into the yellow or orange. It will operate effectively either way, but don't go yellow-orange and expect them to work. That would not work effectively. So yellow, orange. In this case, they're different colors for each different type of motherboard that's out there, but the concept again is the same. There'll be 2 different colors. You'll be able to visually see that. You could probably open the computer that you have at home and visually see that. Now, you can get these DIMMs in multiple sizes, if you will, or multiple capacities. You can get them in 2 gig, 4 gig, 8 gig, 16, 32, 64 gigs capacity. And so if you do that, you have to have an even pair that it's going in. So if you have two 64 gig capacities, you're going to have the 128 gigabits of memory that goes in your computer. You're going to want to make sure that the amount that you're putting in your motherboard or the BIOS, the basic input output system chip on your motherboard that drives the basic fundamental understanding, if you will, that loads up into the motherboard, the software, if you will, that loads up into the motherboard can take that capacity. Most computers today will take 128 or 256. Now you'll notice that I went through a series of numbers there, and you can't, for example, get 6 gig cards. It's going to be 2, 4, 8, 16, 32, 64s, or even up to 128. Usually you're not going to find 128. It's going to be 64s. And if you want 128 in your computer, you would have the pair 64 plus 64. But we're starting to get that point where you might start seeing a dual 128s. What a lot of people can do in order to get to 128s is they can do 32, 32, 32, 32, and get to what you need. So again, you always have to have pairs, but you can have two sets of pairs, and whatever you have in one slot, you have to match it in the other, and you cannot also for example, have 32, 32 in the yellows and 16 and 16s in the oranges. You would have to have 32, 32, 32, 32 across the board. Or if you wanted, 64, you would go 16, 16, 16, 16 kind of scenario. So that gives you a little understanding of DIMMs, a little understanding of RAM, how to deploy that, what the memory slots look like. Again, the only way that this is going to work is if you folks offer your questions through email or otherwise. So you can reach out to me at MHOUPT@Common Sense Security, all one word, commonsensesecurity.net. I look forward to your questions, and I hope you've enjoyed episode 4 and getting to understand sockets and slots.